Welcome back, everybody. Today we are going to begin our study of different market structures. These different market structures will help us identify how price and quantity are determined based on the characteristics of the market, and will help us to identify how efficient or inefficient they may be. We're going to start by looking at what's known as perfect competition. So our goal is to be able to explain the conditions under which perfect competition exists and be able to determine how to find the profit maximizing output in a perfectly competitive market. So when we're talking about market structures, we're saying that they are dependent, the type of market structure we have is dependent on two different variables. One is the number of firms that exist in the market, and the second is the nature of the product itself. Is the product identical in nature across all companies, or are the products that each company makes different in some way, either real or perceived? And the answer to those two questions determines what type of market we're looking at. When it comes to differentiated products, we're talking about products that are in some way either the same or different. Differentiated means that they are different in some way. It doesn't necessarily mean in any substantive way. It could just be in the minds of consumers. They view it as being different. So we're looking at different products: corn, cars, gas, breakfast cereals, number 2 pencils. Think about which of these you think are differentiated in some way, and which ones do you think are identical? I mean, if we think about it, corn is corn. Corn is an identical product pretty much across all farmers. Nobody really worries whether the corn came from your field or my field. It's pretty much the same in general. Though for some people that live in agricultural areas, they may argue that they use different seeds or something like that. But for our purposes, when we think about corn, corn is corn. Cars, on the other hand, are unique, right? Each car has a different style, a different set of features, engines, seats, what have you. So cars are differentiated. Whereas regular gasoline, it doesn't matter where you get regular gas, whether it's at Shell or Sunoco or wherever you go, it's all the same. Number 2 pencils are basically all the same. Again, there is some differentiation within the number 2 pencil market in reality. The Ticonderoga pencil is clearly the superior pencil, as just about everybody in education knows. But outside of that, when it comes to a number 2 pencil, if it's yellow, has an eraser, and you can sharpen it, a pencil is a pencil. And breakfast cereal, clearly differentiated. There's different shapes and colors and flavors and all these different things. So we would say that breakfast cereal is a differentiated product. So the answer to the question, how many firms are there and are the products differentiated, drives the market structure we're talking about. So we will be covering over the course of the next several lessons perfect competition, monopoly, oligopoly, and monopolistic competition. And as you're going to see, if there's only one firm, then it's a monopoly. Mono means one, so one firm in the market. There is no situation in which there's one firm with differentiated products. There's a firm. It's the only firm that produces the product. So it's just monopoly. Oligopoly will be a few firms, and it doesn't matter what type of product they're selling. If there's a few firms, as we'll find out, that means that they can collude or work together. And then if the answer to how many firms are there is many, then we're either dealing with perfect competition or monopolistic competition. So many does not have a specific definition. Many just means more than a few, meaning that they cannot work together to collude. And so if there's many, many firms and they're producing identical products, then we're talking about perfect competition. If there are many, many firms producing unique products, then we're talking about monopolistic competition. And we'll get into more specifics about each one of those as we move forward through the lessons. And when it comes to perfect competition, we're going to make a few assumptions. One is that there are many firms in the market. And when I say many firms, again, what I mean is there are so many firms in the market that no one firm can have an impact on the equilibrium price and quantity, which means that everyone who's in the industry, every firm that's making this product, is what's known as a price taker. They cannot set their price. The market sets the price, and everybody charges that same price, no matter what. And the reason why they cannot sell the product for more or less than what the market price is because they're selling identical products. So it makes no sense for you to charge anything more than the market price if you're selling the identical product, because as consumers, we have a choice. We can either buy yours that costs more or somebody else's that costs less. At the end of the day, it's the exact same product. So why on earth would I pay more for yours when it's no better or worse than somebody else's? So you can't charge more. And you wouldn't charge less either, because people are willing to pay more for your product. So why would you charge less? If your goal is to maximize profit, you're going to charge what people are willing to pay. So you're not going to sell your product for more than the market price. You won't sell it for less than the market price. You're going to sell it at the market price, because whatever the market dictates, that's what you can charge. And that goes along with, again, this idea of identical products. These products are exactly the same. There are also no barriers to entry, meaning that firms can either enter the market or leave the market without cost. So we can look at some data for a perfectly competitive industry. And we can see in a perfectly competitive industry that there is a relationship between price and marginal revenue. First off, a reminder, marginal revenue is the change in total revenue divided by the change in quantity. So if I go from 0 to 1, I go from $0 to $8 in total revenue. So my marginal revenue would be 8. If I go from one product to 2, then my total revenue goes from $8 to $16. So the change is $8. In fact, the change is $8 all the way down the line, no matter how many goods I sell. So that gives us some invaluable information about the relationship between price and marginal revenue, which is that in perfect competition, price and marginal revenue are the same, because the price will always be the same for as many goods as you sell, because there are many, many firms in the industry, making each firm a price taker. We can also identify the optimal output by using our optimal output rule, that rule in economics, which says the optimal output, the profit maximizing point, is the point at which the marginal revenue equals the marginal cost. So in this case, marginal revenue always being $8, I look for the marginal cost to see where it equals $8, and that will be our profit maximizing point. In this case, the best option for me if I'm a firm is to sell 5 units, because at 5 units I will have more profit than at any other point that I could produce. So the optimal output rule says marginal revenue equals marginal cost. We also know that price equals marginal revenue, which means that in perfect competition, we know that marginal revenue equals price. We should also recognize that that means that it is also the demand curve for an individual firm. Firms will charge the market price and will sell as many goods as people want at that price. The demand curve for a perfectly competitive firm is perfectly elastic. If I charge 1 penny more, nobody will want to buy my stuff. If I charge 1 penny less, basically everyone in the market will want to buy my things. But neither one of those two options makes a heck of a lot of sense, as we just talked about, and so firms will charge the market price. So when you're graphing a perfectly competitive firm, you'll draw a horizontal line at the market price and we'll label it marginal revenue equals price equals demand. It's also equal to the average revenue as well. It's all the same, really, because revenue, the average that I'm selling is going to be the same as price, because the price never changes. So to find the optimal point, I again look for where marginal revenue equals price equals marginal cost. And that will be my profit maximizing point. The next question then is, am I earning a positive or negative economic profit, or is it normal? So we remind ourselves that profit equals total revenue minus total cost. And I'll also remind you that we are talking now and forever for the rest of economics about economic profit. We will be assuming that the total cost includes implicit costs, includes our opportunity costs. So if total revenue is greater than total cost, we're profitable. If total revenue is less, we have a loss. If they're equal, we break even. But now we know some more stuff too, with some basic math. We could look at profit per unit. We could take that profit equation and divide by Q. So that we know our average revenue or marginal revenue is total revenue divided by Q. And we know that average total cost is total cost divided by Q. But we also know that total revenue divided by Q equal to marginal revenue is equal to price. So we could substitute in here. We could say the profit per unit is equal to price minus average total cost. And that will help us visually determine whether or not there's a profit or not, because we will be able to compare the price at the optimal output and the average total cost at the optimal output. We'll see which one's greater, and that'll determine whether we have a profit or a loss. If price is greater than ATC, the firm is profitable. If price is less than ATC, it has a loss. If price and ATC are the same, then we have normal profit. So in this case, on this graph, we can see that at the market price of $14, the marginal revenue is equal to the price, and that intersects the marginal cost curve at a unit of 4, and it also intersects with the average total cost, which means that price and average total cost are the same. So therefore, in this graph, there is no profit. We have what's known as normal profit. We are no better off in this industry than if we were in another industry. We could take a second to practice this. So here's your opportunity. Look for and try and identify the optimal output, assuming that the price equals $9. So using the fact that we know that price equals marginal revenue and knowing that the optimal output is marginal revenue equals marginal cost, take a moment to see if you can calculate the optimal output. So press pause, see what you can come up with, and then when you're ready, press play and see how you did in determining what is the value of Daphne's profit or loss. If you work through the problem, hopefully you got this answer. We know that marginal revenue equals 9. We calculated marginal cost in that right column. We looked for where marginal revenue equals marginal cost. We saw that that happens at a quantity of 6. So that's the optimal output. So Daphne's producing 6 units, selling them at $9 a piece. So total revenue is $54. We can also look at this table. We can see the total cost is $39 for a quantity of 6. So we've got total revenue of $54 minus the total costs of $39 tells us that Daphne has an economic profit of $15. She's earning $15 more in this industry than she could if she had entered into her next best alternative. We're going to get back together next time and talk more about how to graph perfect competition, and I'll talk to you then.